Hello world, this is Leo and today I am going to set you up to fully understand 2D movements in Godot, and we will have a look at the two most important ways on how movement in 2D space is being implemented. Those are going to be a top-down movement in a 2D space and also the classical side-scrolling aka platformer 2D movement. Understanding 2D movements all starts with understanding vector 2 coordinates. The two-dimensional space that we're navigating in a 2D scene is made of x and y coordinates. Everything that is horizontal, to the right and to the left, that is the x-axis that we move on. Everything that is vertical, that is the y-axis. And the coordinates, which you will see a lot, the vector 2 of point 0 and 0. This means that the x-axis has the value of 0 and the y is of value 0. But what does that have to do with movement of our character? If we go to an empty scene and we just add ourselves a sprite into it, you can see that the sprite has a position. And the position of the sprite is determined by x and y. If I increase my x by 100, for example, that means I move my character to the right by 100 pixels. If I reduce it and go, for example, below 0, I go to the left. If I just click it and drag it around, you can see that my x and y coordinates here are automatically updating to always capture the position where I'm currently in. So setting this to 0, 0 and to 0 here brings us back to the initial position where everything starts. Those of you who are quick to catch on might have already noticed that position in this case is a variable with the type of vector 2. What do I mean by that? I mean that a variable can have any type, right? It could be an array, it could be an integer, it could be a string, etc. Or in our case, it is the type of vector 2. And in code, it would look like this. So we can declare our variable and we will have to give him an x and a y value so that he can make a coordinate out of it. And here are also some very important variables that we are going to define as a vector 2 later on. So what we have learned here is that if we want to move a character on our screen, we will have to add or subtract from the x and y values of their position to move them along the axis. Let's jump to the scripts and see some practical examples. First, we'll go with the easier one, which is top-down movement. I have already prepared a script for it, which we will now go through bit by bit. And I promise, with the knowledge that we have from before, it will be easy. So first we have declared a variable that's called direction. And this variable is, as you might have guessed, of a type vector 2. Currently, this variable, we have assigned it the value of 0, 0. And if you remember what we just said, the direction in the x and y axis is if we want to go to the right, we would give it a 1. If we want to go to the left, we would give it a -1. And for the y axis, obviously the same. If we want to go down, it is the 1. And if we want to go up, it is the -1. Now what else do we have? We have a movement speed variable that we declared, which is going to determine how many pixels we are going to move on the screen every second. And how this is all going to come together is later when we set the velocity, and I'm going ahead of myself here. When we're setting the velocity, this is going to be the direction, which is 1 pixel per second in a certain direction, up, down, left or right, multiplied by the movement speed. So this is going to determine how much do we move every second. Delta is the one that makes sure that we are actually locking all of this data onto a universal time scale, which is our seconds, minutes, and hours. Delta is going to alter all this equation in a way that it's always the same speed for everyone, no matter on which PC they are working with. We have two functions here now. The first function is very simple. It is only calling our move character function, which we have down here and is defined down here. And here goes the logic for our move character. It is only 4 lines of code, and then we call the move and slide function, and I'm going to explain them bit by bit for you. Sorry, me from the future here. While shooting this video, I accidentally forgot to show you how you can make your own key bindings and input settings inside of Godot. The right, left, down, and up that you can see written here are declared by me and are not standard. I will add this part to the end of the video, so stay relaxed and just keep watching. First, we are declaring two variables, and these variables are called move x and move y. And they are only going to store for us in which direction we are just pressing our buttons. It gets the input from our keyboard and he gets the action that we do, which could be either right or left, and he gets the strength of it. Now think of it this way. So the strength of our button press is going to be 1. If we want to go to the right. Remember, that means we are going in the direction of 1 and 0. If we were to press the button to go to the left, that would also call this function and would subtract 1 if we press to the right, minus 1 if we press to the left, would return to be 0. Else, if our function is 0 anyway, because we're not pressing right and we're subtracting 1, that means our function turns into minus 1 and we go to the left. The same thing and the same principle applies for up and down movement that we check in a move y variable. Now we have stored whether we're going left or right, or we're going up and down with these two functions. The next thing that we do is we construct a vector 2 out of it. So the direction that we have already declared in this update, whenever this move character function is called, we'll ask, am I going up, down, left, or right? And then we're feeding this information into the direction that we want to move in. And we give it the move x and the move y as the values for the x-axis and the y-axis that we want to move. And then the only thing that's left is define our velocity. The velocity will be fed into the move and slide function, and this move and slide function is one that is specifically designed only for the character body 2D, and it's going to handle the movement. To handle any movement, it needs a velocity to be set, and that is what we do here. We will set the velocity that our player has by saying that it goes into the direction, which is up, down, left, or right, and we will multiply it by our movement speed, as we said before. Now, there is one thing that we haven't seen yet, which is the dot normalized function, which is going to make out of our direction a value between 0 and 1. And this way, our diagonal movement is just as quick as our up, down, left, and right movement. Okay, so this was easy enough. And of course, you can add a lot of functionality on this. But that's already it. Very, very easy, right? We have a variable x, a variable y. We pass it into a vector 2 so that we can know our direction. And then we multiply the direction by our movement speed and store it into the velocity. And then we call the move and slide function and everything does itself. Good. Now let's go to the second example, which I obviously already have prepared. And here we want to move our character on this 2D scene that I prepared through a tile map. And I'm going to detach the script here and I will now add a new one. And this one is only going to be called player. Note that there's a template for character movement. And if we create it like this, it is going to show up a whole bunch of things on our screen. You might have been able to come this far, and effectively this is exactly the script that we are going to use to move our character in a 2D platformer scene. But if you press play and you have your platform and everything enabled and you're happy with it and you want to go and jump around, this happens. You just fall through. That is something that is easily fixed if we go into our tile map for the platform. You will have to tell him in our tile set, if we click on here, that you need the physics layer. We then go into our tile map and on the tile set down here and hit paint. we can paint a physics layer on top of our tiles. Note that this can be done in excruciatingly detail. For the sake of this, we're going to keep it very simple. Now, if we hit play again, actually it works and we can start moving around. Now let's jump into the script and see what's happening here. What we have here, the very first two things declared are constant, which is speed, and the constant, which is a jump velocity. This is determining how high can we jump, and this is determining how fast can we run. You might want to consider making this a variable, not a constant. A constant means I cannot change this speed by any means, and it's always going to be 300 and a float number. You can obviously later, if you have a buff or anything, multiply it by 2 to make it double the speed. That works, but it will not be permanent. And getting very messy if you want to have permanent changes. The next thing that we have is a gravity. This determines how fast we will fall if we run off a cliff. And that is the reason why we fell through our scene when it had no collision shapes on it. The gravity can be changed obviously by simply hard typing it here, like I could make a 900 out of it, but I don't suggest doing that because you want to have the gravity the same for all the bodies in your scene. Instead, it tells us exactly where it is. We can find it in the project settings, and if we look that up, the project settings, and try to find gravity, you have here in the physics, you have 2D gravity, and we can change this like this. And you will see we now suddenly can jump higher and the movement is more moon-like. Great. And then what we have is a physics process function, and that's already it. Yeah, it's a bit long because it handles different things. For example, it has a function in here which is saying if our character is not on floor, then gravity should be applied to our velocity. Else, if we are on floor, he is not going to try to push us into the ground. He is completely ignoring this. Then the handle jump. Only if we are on the floor and our action UI accept is being pressed, we are going to jump upwards. We're going to add to our velocity y the jump force. Then obviously the check is on floor will be negative and our velocity.y will decrease again over time until we hit the floor again. So this basically is all just jump and falling. Easy as that. And then what we have is a variable that's declaring our direction. And our input, where we get the axis, is this is going to be either 1 or -1 on the x-axis because we're only moving left and right. There's no up and down movement. The only up and down movement we have is jumping and gravity. Good so far. Then we do a check if we have any direction set and it's not 0. Then we multiply direction times speed to get our velocity for the x-axis. And if we don't have any direction, if it's nothing pressed, if we are on 0, we have a function here, move toward, which is going to gradually again going to decrease our speed until we hit 0. And then we call the move and slide function, which is taking our velocity that we have set here on the y and on the x and is going to handle the movement for us. And that's pretty much everything there is to it. If anybody is interested on how Delta is working, I can drop a short video about this later. Just let me know in the comments below. Now let's move to what I promised, which is the custom input settings, or let's say custom keybind inside of Godot. The UI accept that you see here and everything that has an underscore and UI and underscore is already preset by Godot. But you can also determine your own names for key bindings and what they should do. And that is easily done if you go to projects and into your project settings. And inside these project settings, you have the input map. Here, all key bindings are being set. The left, right, up, and down, as you can see, are the ones that I added here. Let's delete them for the time being. You can also see all those built-in actions that already exist by toggling this button here. And you can see that UI accept, for example, accepts enter, the KP enter and space as valuable keys to trigger UI accept. That means that in our script here, you can jump. This is our jumped action. You can jump with all of these 3 keys. Let's go back into the settings and set something up for ourselves. Let's get this away. And we are going to rewrite the key bindings that I just deleted. So the one was right, the other one was left, the other one is up, and the other one is down. Now you can name this, you can name them whatever you like, but you should have some logic to them. Like I can call this Captain America, but will I later, when I write my code, know what this means or what button is bound to it? Probably not. To add a button to one of these actions, you press this plus sign, and here you can either go painstakingly scrolling through all the possibilities, or you can just click up here and press the button that you want to bind it to. In my case, right is D. He automatically finds it, and we can just press OK. For the left, it's A. For the up, it's W, and for the down, it is S. And just like that, you can do your customized key bindings and use these notations later in your code. Let's move back to where I used it. Remember that you have to have these quotation marks if you want to get an input event, and you're ready to go. Let me know if you found this video useful, and as always, much love and ciao, ciao.